Hi everyone, this is our new video to know how can we actually crack RSA algorithm and why is this very secure algorithm and very hard to decrypt and find the private key. Okay, for this example we have here our public key which is E and N. So how can we actually get the private key? Private key which is D. So in this scenario we have N equal to 33 which can give us P and Q because N equals P times Q. So in this scenario, P and Q should be prime numbers. So we can just say it is 3 times 11, which give us 33. There is not a lot of options when it is a very small number. So now we can get phi of n. Phi of n is equal to P minus 1 times Q minus 1. So in this scenario, it will be 20. So given phi of n, we can get d because d times e modulus phi of n equals to 1 because d and e should be relatively prime too. So in this scenario, we have e equal to 3, so d should be 7. So here it is, we got the private key and it's easy. But no, in real life scenarios, n is very large. N can be around 200 digits or more. So it's computationally impossible to get D or the private key. Let's go through this example here. Here we are trying to factorize n, small n, medium and large, and very large n. So in this example, we can just run the code here and see we are getting the first factors easily, second and third easily, but for the third one, it is a very large number, so the computer will just keep computing it for a lot of time. If it is a very large number, it might take years to compute it, so that's why it's a very secure algorithm, because security is about how it is secure computationally when it comes to encryption.